Welcome, curious minds, to another adventure into the amazing world of how things work. Today, we're tackling something that feels a bit like magic, but I promise you it's just super clever engineering. How a computer, or what we often call artificial intelligence, learns.
Oh, AI. Like the voice assistant on my device? Or the programs that recommend what to watch next? Sometimes it feels like they can read my mind, or even predict what I'm going to do before I do it.
Exactly. It's easy to think there's some kind of wizardry involved, but the truth is, these smart systems aren't magic at all. They don't have feelings or dreams or even true understanding the way a person does. They're actually more like incredibly dedicated students or super efficient librarians.
A dedicated student? A librarian? But they seem so spontaneous sometimes. Like when I ask my voice assistant a weird question, and it usually has a pretty good answer.
That's a fantastic observation, Alex, and it gets right to the heart of what we're exploring today. The core idea is incredibly simple. AI doesn't think in the human sense. Instead, it does three main things really, really well. It looks at a huge amount of stuff, it listens to a huge amount of stuff, and then, based on all that looking and listening, it learns to make a very, very good guess about what comes next.
Hold on. Looks at a huge amount of stuff, listens to a huge amount of stuff, and then guesses? So it's like, if I want to learn to play a new video game, I watch a ton of videos of people playing it, I listen to all the tutorial dialogue, and then I try to guess the best move?
That's a brilliant way to put it, Alex. You're already grasping the core principle. Think of it like this. Imagine you're a super chef and you want to bake the most incredible chocolate chip cookies. You don't just magically know how to do it. What would you do?
Well, I'd probably find a recipe, or maybe several recipes, and then I'd read them, gather all the ingredients, and follow the steps.
Precisely. Now, what if you try a recipe and the cookies turn out a little too crumbly or not sweet enough? What would you do next?
I'd probably try another recipe, or maybe adjust the one I had, add a little more sugar or a bit less flour next time. I'd learn from my experience.
You got it. That's exactly how AI learns. It's fed tons and tons of recipes, which we call data, and then it tries them out, gets feedback, and adjusts until it gets really, really good at making the perfect cookie, or in our case, the perfect guess.
So the data is like the ingredients and the steps in the recipe? And the feedback is like me tasting the cookie and deciding if it's good or not?
Exactly right. Now, let's break down those first two parts, how AI looks and listens, because it's not like you or I seeing with our eyes or hearing with our ears. It's much more mechanical, but incredibly powerful.
Okay, so how does it look at things? Like pictures? I take pictures with my phone all the time, but my phone doesn't know what's in the picture, does it? Not usually.
But with AI, it can. Think about it like building with Legos. When you look at a big, complex Lego castle, you don't just see a castle. You see lots of individual Lego bricks, a red square, a blue rectangle, a little archway, a tiny window brick, right?
Yeah, I see the individual pieces that make up the whole thing.
Perfect. That's how AI sees an image. It doesn't see a cat or a tree in the same way you do. It breaks the image down into its tiniest parts, like those individual Lego bricks, which for a computer are called pixels. Each pixel has a color and a brightness. Then the AI looks for patterns in how those pixels are arranged.
Patterns? Like what kind of patterns?
Good question. Imagine you're trying to teach a computer what a ball looks like. You show it thousands, even millions of pictures of balls. Big balls, small balls, red balls, blue balls, soccer balls, basketballs, even a ball of yarn. And in each picture, you tell the computer, hey, this is a ball.
That sounds like a lot of work for a person to do.
It is, but it's how AI gets its initial education. As the AI looks at all these pictures, it starts to notice recurring patterns. It might learn that a ball often has a round shape, or that it has a consistent texture, or that it usually has a smooth, curved edge. It's not thinking about a ball, it's just recognizing these pixel patterns that tend to appear together when humans label something ball.
So it's like it's collecting a huge mental album of ball shapes and colors. And then when it sees something new, it compares it to that album.
Precisely. If a new image comes in and it has enough of those ball-like pixel patterns, the AI will guess with a high degree of confidence that looks like a ball. It's like your Lego analogy. If you see a new pile of bricks and many of them are the same kind you've seen in other castles, you might guess this is probably for building a castle.
Okay, I think I get the looking part. It's breaking things down into tiny pieces and finding patterns. What about listening? How does it hear language?
The listening part works in a very similar way, but with sounds and words instead of pixels. Imagine you're learning a new secret code. Each sound, each word, each syllable is like a different symbol in that code. When you hear people speaking, you're not just hearing random noises, you're hearing sequences of these symbols.
Right, like when I hear the word hello, it's two distinct sounds, he and lo, put together.
Exactly. For a computer, it takes those sound waves and turns them into numbers. Just like pixels are numbers representing color, sounds are converted into numbers representing pitch, volume, and timing. Then the AI looks for patterns in these numerical sequences.
Patterns in sound numbers? That sounds tricky.
It is, but it's incredibly effective. Just as it learned what a ball looks like by seeing many pictures, it learns what the word hello sounds like by listening to thousands, even millions of examples of people saying hello, from different voices, different tones, different speeds. And each time, a human has usually told it this sound sequence means hello.
So it connects the pattern of numbers from the sound to the meaning of the word hello.
Yes, and not just individual words, but also how words fit together. Think of it like reading a story. You don't just understand each word individually, you understand how they form sentences and how those sentences form paragraphs, creating a larger meaning. AI learns these patterns too.
So if I say, what time is it? The AI breaks down the sounds, matches the sound patterns to the words what, time, is, it, and then understands that sequence of words means I'm asking for the current time?
You've got it. It's like it has a gigantic mental dictionary and grammar book, but instead of human rules, it's all built from observing patterns in countless real-world conversations and written texts. It's learned that when those specific sound patterns come in that specific order, the most probable response is to provide the current time.
That's a lot of looking and listening, and all those examples. It sounds like the AI needs a really good teacher.
You've hit on a critical point, Alex. The learning from many examples is where the real magic, or rather, the real hard work happens. We call this training. Imagine you're teaching a young puppy to sit. You don't just tell it sit once. You say sit, you gently guide it into the sitting position, and when it sits, you give it a treat and praise. Repeat this many, many times.
And eventually, the puppy learns to sit on command, even without the guiding hand, just by hearing sit.
Exactly. The AI learning process is remarkably similar. For every picture it sees, every sound it hears, every piece of text it reads, it's often given a label, a human-provided answer. This is called label data. So for pictures of cats, it gets the label cat. For a sentence asking a question, it gets the label question.
So the treat for the AI is getting the right label?
In a way, yes. When the AI makes a guess, say it predicts a picture is a dog, and the human-provided label says it's actually a cat, the AI gets a kind of feedback that it made a mistake. It then adjusts its internal patterns, like tweaking a complex formula, so that next time it's more likely to guess cat for similar images.
Oh, like when I bake those cookies. If they're too crumbly, that's my mistake, and I adjust the recipe.
The AI does that, but super fast and with millions of recipes.
Precisely. This process of guessing, comparing its guess to the correct answer, the label, and then adjusting its internal workings is repeated millions, even billions of times with vast amounts of data. This is how it learns. It's not understanding, it's becoming incredibly good at finding intricate patterns and making highly probable predictions based on those patterns.
Okay, so it looks, it listens, it learns from examples by getting feedback, and then it makes its guess. How good are these guesses? Really? Are they just random?
Not random at all. This is where the sheer volume of data and the sophisticated pattern finding come into play. Remember our chef? After making hundreds of batches of chocolate chip cookies, adjusting the recipe each time, that chef gets really, really good at predicting exactly how much flour, sugar, and chocolate chips to use to get a perfect cookie every single time.
So if I ask the AI, what's the weather like today? It's not just randomly shouting sunny or rainy.
Absolutely not. It has looked at vast amounts of weather data, historical temperatures, humidity, wind patterns, satellite images. It has listened to countless weather reports and forecasts. It has learned the intricate patterns and relationships between all these different pieces of information.
So when it guesses the weather, it's like a super experienced meteorologist who has seen every weather pattern imaginable.
Exactly. It makes a highly informed prediction based on all the patterns it has observed. It calculates the probability. So it might guess there's a 90% chance of rain or a 70% chance of sunshine. It doesn't feel confident, but its calculations show a high likelihood.
So when my video game recommends a new game, it's not guessing randomly, it's guessing based on all the games I've played, liked and disliked, and comparing that to what millions of other players have done.
Spot on. It sees the patterns in your preferences, the patterns in games you've enjoyed, and the patterns in what similar players have also enjoyed. Then it guesses what game you're most likely to enjoy next. It's not thinking Alex likes fantasy RPGs, but rather, based on past data, players with Alex's profile have a very high probability of enjoying this specific fantasy RPG next.
This is making so much more sense now. So AI isn't a brain that thinks, it's more like a super-powered pattern detector and prediction engine.
That's the perfect way to summarize it, Alex. It doesn't understand in the human sense, but it can find incredibly complex patterns in massive amounts of information, far more than any human could process. And based on those patterns, it can make remarkably accurate and useful predictions, or guesses. It's like when you've watched so many cartoons, you just know who the hero is and who the villain is without even having to think about it. The AI does that, but on an astronomical scale, across every kind of information you can imagine.
That's a mind-bending idea, but so clear with the examples. So the smart parts of our devices aren't magic, they're just incredibly diligent pattern learners and guess makers.
Absolutely. And that's why they can do so many amazing things, from understanding our voices to helping doctors find patterns in medical images, or even guiding self-driving cars. It's all about looking, listening, learning from countless examples, and then making the best possible guess about what comes next.
I feel like I've just been given a secret decoder ring for understanding how the digital world really works. This is so much cooler than magic.
I agree. There's a true beauty in understanding the underlying mechanisms. It's a testament to human ingenuity in building tools that can process information in ways we never could before. So, next time you interact with a smart machine, remember its secret. It's not a wizard, it's just a master of observation and informed prediction.
I'll definitely be thinking about those Lego bricks and cookie recipes from now on. Thanks, Jamie.
You're very welcome, Alex, and thank you, curious minds, for joining us on this exploration. Keep asking questions, keep looking for patterns, and keep exploring the fascinating world around you.
Until next time.
Goodbye.